Parthasarathi Mukhopadhyay, our Partha actually, how we call him. Did his bachelor's and master's in architecture from Jadavpur University. He received his PhD from IIST, Shibpur, and he is presently a professor in the Department of Architecture, Town and Regional Planning. He has 39 publications and 2 Indian patents to his credit. And his areas of research are disaster-resistant architecture, bamboo as a design element, rapid visual screening, urban semiotics, etc. He is co-innovator of low bamboo energy bamboo concrete flooring, which was one of the top 7 entries in Lafarge Invention Awards 2011, and subsequently a co-inventor of engineered bamboo houses. Since 2016, he has been elected as an alternate member of the panel for timber and bamboo under National Building Code of India. So, Partha, over to you.
Actually, honestly, I should thank Cave and Obin and you and everyone for giving me this chance to talk a little bit. And I'm very much awed by seeing one of my teachers, third year, second semester, external is present here. So, those of you who know a little bit of Bengali, there is a particular word, je baans diye dekho. So, the issue is that when Obin talked with me about what should be the topic, he was saying baans nahi about it, and then I said, yeah, you're given a very difficult task to give baans to everyone, but in a manner in which is palatable. So over to the topic, this will be a very much informative lecture, no hardcore research. People who are working with bamboo will be knowing many of what I was talking about. I hope that at the end of the talk, there will be a half an hour, 35 minutes talk, for which people who may be interested we can discuss later on about results. So, I will be shifted on the good channel. Look at a PDF file.
PowerPoint has it? PowerPoint?
Escape. Manna. So we will discuss today the following issues. First of all, what is the image of bamboo for us? To call bamboo. Then availability of this tropical grass. Bamboo is actually grass. See. Thirdly, how is it being used as a building material in India? How much? And its influence on architecture of tropical India. And this sustainability is there. So, what is the greenness of bamboo? And the structural versatility of bamboo. And we will also discuss about how it was being used for many number of days, but how it has been rediscovered now with company works. So, this is a very familiar picture if anybody goes to a village, of Bengal. Typical skeleton of a typical bamboo building. Actually, this was taken when we were going for a survey, reconnaissance survey of a cyclone cedar. It happened in 2007. Now, this is a picture of a Toraja house in Indonesia. These Toraja people are basically who goes to the seamen. So you can see the buildings as a form of ships. Because they correlate with the building with their way of living. But the material is bamboo. Now I was talking about the cyclone cedar. It was actually happening mainly in Bangladesh. And I happened to go to the poorest of poor people living in the Sundarban part of Bangladesh. And there also we found that the poor people also do not want to have their building made with bamboo. The option is timber is available, then go for timber. If nothing is available, then only go for bamboo. So bamboo is basically poor man's timber. Now if I come to the city, the image is bamboo means you are using it for scaffolding purpose. Or this is a picture from Chennai. Somebody is on the ladder, bamboo ladder, painting on a street light in Chennai. So this is the urban image where bamboo means you are using it for these purposes. Now, keeping this image in mind, if I want to go through where it is available, if I say, it's in Asia, Africa, and America, and basically along the tropics it is being available. And if you can see, a huge part of that is India and China. In fact, China is the biggest bamboo producer in the world, and India is second biggest. And so India is only 45% of world's bamboo forests. And 136 bamboo species in 30 genera are available. One of the principal two genera are Dendrocalamus and Bambusa. These are the principal two genera. And if India's area is 329 mega hectare, and forest area is 63.34 mega hectare, bamboo growing area is 8.96 mega hectare. And out of this, 4.5 ton of bamboo is annually produced in India. Now, if I come to a breakup of this thing in table 1, you can see that the northeast is the major contributor. The first column is the percentage of area. So that is the breakup of this 8.96 mega hectare. That breakup is this one. And 4.5 megaton, this is the breakup of that. So what is the volume of bamboo is being there, and what is the area there is being grown. So you can see that West Bengal is there and the other states. It is contributing having an area of something around 2-3% of the total area. So you have plug them up, Kerala, UP, Jharkhand, West Bengal together at 20.2%. So, and definitely these species are all different. If you go to northeast, you have such species which are, but if you visit this botanical garden in Kolkata, there we have different species of bamboo which are available in different parts of India are present in that garden. Now, if I want to really look into the fact that how many buildings are actually made of bamboo, and this is the census 2011 data. So, as per the data, this is the name of the predominant building material as per the census data. Okay. So, this 28.6, that is this grass, thatch, bamboo, wood, mud, etc., they have clubbed them together, and handmade tiles clubbed together as non-engineered materials. They contribute 28.6% of the predominant roofing material. Okay, and whereas the non-engineered material, bamboo roofing material is the highest one among the non-engineered ones, and after mud, the second highest one is walling is again bamboo, grass, bamboo, thatch, etc. Here I should take this opportunity to clarify the term engineered, non-engineered. You see, if there is a material whose characteristics is known to us, what is its load bearing capacity, etc., everything is known to us, and how do you engage that in construction? If it's known to you, then it's the engineering. Okay. And if nothing is known, there is a non-engineering. But there is something in between. For example, if the code says the external wall should be such and such millimeter thick, say 1 brick thick or 200 millimeter thick, but you are making a 125 millimeter brick thick wall, then that is a non-engineered application of an engineered material. So semi-engineered pieces. So if the brick is first class brick or second class brick because it's clarified so much is your load brick. But if you use a Jama brick, then that is absolutely non-engineered because there the property of the material is also not known, the process is also not known. So you have a building whose suppose the plinth level is made of traditional way, and then after that you are using bamboo, it's semi-engineered. So you can have combination of materials or material and process. So that is semi-engineered. Engineering is fully known and non-engineering is absolutely known. So this is the situation as far as so definitely we understand that if I say 28.6 and 34.3, if I say that okay fine, some are common, I don't know how much is common. Some are having roofing and walling, both of these things we don't know suppose. So if I say suppose 20% people are using, so that means around 60 million people are living in buildings made of bamboo, and they can't pay architects and structural engineers as their clients and consultants. So they are the people who are majority. So therefore what I want to say is this, that therefore bamboo is involved in their life so much that definitely it influences culture to some extent. Okay. So if I can quote Pope here, that there is evidence to suggest that bamboo was utilized by Homo erectus in Southeast Asia 1 million years ago. So it's been used since the human civilization is existing. And when we are in second year or first year, we study this evolution of architecture or history, what is the name? We normally study the buildings of temples and kings' palaces and the forts and all these things, but we don't seldom have the opportunity of studying dwellings of common people. But definitely the humble dwellings, they are a cultural phenomenon. They reflect what is the material, and bamboo is the material for a huge number of people, especially in the Latin America. There's countries like Colombia, countries like Ecuador, and in Southeast Asia, like the Far East, Japan, China, and all these places, and our place is obvious. And now, what has happened in India? The place where bamboo, though the quantity of bamboo is more available in Northeast, but the place where bamboo is being used as architectural medium is Bengal. And you see this cambered roof. This is a typical thing of Bengal. And this is also known as Bangala roof or Charchala roof. And this has been so much liked by people. I'll come to the next slide where I'll show that it has you see, if you go back to your, again, school days, university days, look at Buddhist architecture. We'll see that before Buddhist architecture, there was this timber architecture. And so timber was copied on stone. So similarly, bamboo architecture copied to timber architecture, copied to stone architecture, or brick architecture. So the material is changing, but the idiom is there, that particular shape they are continuing. In fact, these are two examples of Bengal. One is the Islamic idiom, and one is a Hindu idiom. Fateh Khan Samsuniya with the name Bangala roof in gold, and this Jol Banga temple. So, if you look at the typical structure of a temple, of a masjid, you will think of a shan. There is no shan here, because climate has that much influenced us that you cannot afford to have a shan here, because it is raining for 5-6 months in a year. So it's all inside. So and if nobody tells you what is this, then they're all same. So people are fighting over the street, but actually cutting across religions, this become an outstanding feature of architecture of Bengal for so many days, and this shade is being liked. And we also know that during the time of Akbar, this Bengal and all these things were within the Mughal thing, and Akbar after this victory of the Deccan, he built this Bulanda. So he took cue of this shape and he took it to the Agra and Delhi. One example is the Taj Mahal Agra Fort, where Mughals adopted this style when they reigned over Bengal and spread to Delhi. And we know that there was this matrimonial alliances between the Rajasthanis and the Mughal kings and queens. And that was Sishmal Amber Fort Jai. That's been going, and also it's being told that the Kojbihar Raj family of Bengal, they also have a matronals with the Jaipur Raj family. So from there also it went. But now it has come to it was stone, it is brick, it's no longer bamboo, but the shape there is so much like that people are going with that. And not only it ends here, you can go to the Golden Temple, Amritsar. They have also adopted this thing. So this shows social acceptability of bamboo as an architecture even beyond its origin. Where was Bengal and where is this Amritsar? No connection, but it's being accepted. This shape is but these were all past. These are all past history. What is happening now? Happening now is that 60 million in the census of India who are having no consultant. So the issue is that. So why we are talking about bamboo so much now, today? Because of this world sustainability, because of the greenness thing, because that timber is getting depleted every day. So because there is this issue of replacing timber by bamboo. So we will check how much green is bamboo. Before that, I would like to quote Woodland Commission 87, this very, very, very important definition of what is sustainable development. So it's a development that meets the need for the present without compromising the ability of future generations to meet their own needs. Very, very holistic definition for sustainable development. Now let us see. See, whereas your shal, shagun, or any other timber which is used conventionally for building purpose, they take 15 to 25 years to get mature and then you harvest them. Bamboo takes different species, they take 3 to 5 years for getting maturity. So you can replenish whatever you consume very quickly, and therefore it is sustainable. It's been reported that bamboo survived Hiroshima atomic blast because ground zero. Please imagine ground zero. Ushered first real greening in Hiroshima. So it's very tough. You can tolerate extremes. And effective mechanism to net like root system. See, China has claimed huge amount of barren lands just by planting bamboo. Through this system, they have, 4 years, 5 years they have taken, and then the land has been. Then they have put other plantation. But the original thing was bamboo, which could retain the soil. Then everybody in class 7, we discussed about photosynthesis. Fine, we know that carbon dioxide comes and oxygen goes. But what's special is that bamboo absorbs to the extent of 12 ton per hectare. Some species. This is huge. This is not just like any other tree. It's huge. So therefore, that is a great the issue of carbon exchange, etc., is coming up. So that's a very huge issue India can look after. And if I compare that with the conventional building materials, crude steel, cement, and brick, and with that, we can find that for 1 ton of steel, we need 2.75 emission of carbon dioxide. 0.9 ton of carbon dioxide for producing 1 ton of cement. 1,000 bricks, 0.38 ton of carbon dioxide. But bamboo is not producing, but consuming. So it's a double whammy. So therefore, very much advantages. And obviously, if it absorbs so much of carbon, it have to release oxygen. So therefore, it is releasing oxygen, and to a great extent, 35% more oxygen than human standard trees. So if we are calculating if the energy embodied in a building material, when we discuss these things, so if you compare steel, concrete, wood, and bamboo, you find that the energy is very less. So when your ECBC calculation will be compulsory, the 2016 Act has just come into force. 1,000 square meter above buildings should go by that. I think that is the code, ECBC code is saying, as well as West Bengal part is there. So you can think of this energy embodied in your building. And so all in these ways we can say that bamboo is green. Though it may not always be green, it's sometimes yellow, but bamboo is definitely green. And now, obviously, coming to the question of, okay, fine, we understand bamboo is versatile. As far as the use is concerned, it's green. Then what are the structures? So that you have to look up. I have got 3 slides for this. First is learning from tradition. See, we have all heard this word, look at this particular country, El Salvador. This sort of construction comes in ribs, horizontal ribs and vertical ribs comes there. We have obviously have the Tak of Kashmir, Tak system of Kashmir, or the Jidara of Kashmir, or the Gaura Barik in Colombia, okay, or say the Adobe reinforced with bamboo in Peru, or say Himis of Turkey. So please remember all the names: Turkey, Colombia, Kashmir, and all these places. They are places where earthquake takes place. Okay, and these sorts of buildings are being used. If you go through a report of 2005 Kashmir earthquake, okay, you will find that whether it's in Indian part or POK part, whatever part, you will find that the modern buildings, RCC buildings have collapsed. But the Jidari and Tak system buildings have not collapsed. So this Bengali proverb goes that Mochkai tu bhangen. So it is there. It will stand. It will get a little bit damaged. It will shake, but it will not. So the question is that the simple question is that how people in the past have dealt with overwhelming earthquake forces on structures with technology and materials that were considerably more limited than now. So it's 500 years old, 600 years old. No limited method of calculation was there at that time. Even we didn't do in our student life. So the simple answer is ductile behavior of traditional vernacular non-engineered methods. So this ductility gives, they have studied that thing, okay fine, that it will undergo a little bit of elongation, a little bit of movement, and then it will stay, it will not collapse. So that is basically the key for all these types of, you have different names, but basically they are constructions with bamboo and combination of bamboo and wood. I'm just taking one example here. So this is a dark system of construction in Kashmir. This is a picture of a building after this 2005 earthquake. And I've just drawn a sketch of this main structural components. And you can find these wooden runners are there. You see, the infill walls are there. And so what happens is that when the building shakes, the wooden runners shake, and a lot of friction takes place, and it allows damping, and incremental low-level damage is allowed. You see, if you ask for what sort of damage, if earthquake happens, some damage will occur. You cannot make an earthquake-proof building. You can make an earthquake-resistant building. That means that there will be damage, but life will not be damaged. If it is a low earthquake, building will not be damaged. Irreparable damage. If it is a huge earthquake, the building will be damaged, but at least the people will not, will not die. So this is a thing which is there existing after this earthquake, and big RCC constructions have collapsed because they could manage. The system could manage, though they didn't know a lot of differentiations and integrations, but they could do it by their own observations. So that was learning from tradition. Now talking about some structural properties, there are very general properties which you can very well easily understand. 4 very principal properties. For example, first thing is that if you work with timber, the knots, which we call as gant in Bengali, are the weaknesses. But for bamboo, the knots are the strength. They're much more stronger than the other. So that is a very important advantage. So mechanically more reliable than tin. A. B. This has density, tensile, and composite strength which are comparable with, and sometimes superior in many other kinds. And sometimes, half of that of steel design has been reported. So that is a very advantageous thing, because when you talk about ductility, this property of tensile strength comes into picture. Hardly, if you look at a bamboo, if the volume it occupies but the mass is much less because it's hollow, it's tubular. And therefore, you see, all of us, if we forget everything, we remember P is equal to mf. Newton's second law. Okay? So if F is equal to acceleration due to earthquake, and m is the mass of the body which is suffering earthquake, then the force on it will be P, the product of mass into acceleration. And if the acceleration due to gravity due to earthquake is fixed, then if m is less, then all force on the body will be less. So the whole mass is less, and therefore it will be less. It will be less damaging. You can push a cotton thing just like that. You can't push it like that for a big piece. It will get damaged. It will have more inertial because you can't overturn its inertial rest. So it will take more load. And lastly, which we have discussed earlier, just the previous slide, the morphology of bamboo is being fibers. So that basically uses damping effect. I can just share you. I mean, I don't have the picture with me. I can just share you one information that there was a time when I was breaking many bamboo pieces for my research. Every day I used to break many bamboo pieces. But you see, if you remember this typical Hooke's law, okay. So there is a place which we call as elastic zone, and there is a zone we call as plastic zone. So in the elastic zone, if you withdraw the force, the curve will again come back, trace back the thing. Then there is a critical value goes up, and then it becomes something like that. Now for bamboo, because of so much fibrousness, you have not one thing like that. You have many things like that. So therefore it doesn't break. One thing collapses, the other thing catches up, and it goes like that. So therefore it survives this huge amount of shocks. And then talking about some strength properties, you see, one of the main problems of working with bamboo is that it is not engineered. That means its strength property is not available with us. That is one of the problems. There are 16 species of bamboo which has been identified by National Building Code as structurally suitable. But National Building Code talks about their strength property in green condition. Green condition means just you have felled the bamboo, that strength is available. And in wet condition, we don't use bamboo in wet condition or green condition. We use a dry bamboo, and we use so therefore that data is not there. And moreover, tensile data and all these data are absolutely not there. So this is a place where we can really contribute. These are just one part of my doctoral work where I used to do work with a particular species called Bambusa balkua, which we call in Bengali as balkubash. So that's a common name, balkubash, and Bambusa balkua is a technical botanical name. So you can find the findings is that just like if you go to NBC, go to timber, you will find that there are 3 types of timbers, A, B, C. Similarly, bamboo is 3 types, group A, group B, group C, based on your strength of flexion in bending, how much it can bend. Now, this particular species is basically group B bamboo. This is the strength value which is given in the code. Okay, but for the dry species, if I found out that this strength is much more. Not only much more, it is very much comparable with M10 MP grade of concrete. Okay, it is comparable with that of brick, burnt clay building their strength. From first class to first class is 12.5, second class ranges from 3.5 to 8. So it is comparable with them. And definitely if you look at shal, if you look at oak, chestnut, the trees, okay, then also is comparable. This is a value, this is a value. Why is there are 2 values and why there is 1 value? 2 values because a tree has a girth and therefore the strength varies from the external to internal. But bamboo doesn't have a girth, it's hollow, therefore it has only 1 value. And there is a little bit difference, but we take the least value. So that is a huge difference. And then these values are not available. This is called cleavage strength, which is high for this species, which means you can nail it properly. It will take the nailing thing. And then there is this tensile strength is there quite high. So therefore, this material, if handled properly, can be used for structure, good structures. And you have to 2, 3, 4 stories building the you can go for it. Now, with this background, definitely these things are there, and obviously there is a tendency of it getting rediscovered, especially because this pressure of this global warming, get rid of timber, all these things. So I talked about one of the drawbacks. One drawback is this lack of codification. Another drawback is decay. So 3 to 5 years is the age. So the first work in this work is this 37 bamboo growing in India is a work by Forest Research Institute of Dehradun. They have actually tried to, out of this 139 species, they have actually codified this, found out these 39 species, what are the characteristics there existing. And then there is a body called INBAR, International Network for Bamboo. Rokum means actually bathe, which we call it bathe in Bengali. So that is head office in Beijing. So this INBAR and ICFL, Indian Council of Forest Education, they have together come up with a bamboo preservation technique in 94, and accordingly our codes have been modified, the whole copy paste. Because the Indian person, Mr. Kumar, is there in that body and this body also is copy paste. So they're following that thing. So something is happening as far as the preservation thing is concerned, though some work can be further fine-tuning can be done. The government of India, this 10th plan has come up with this National Bamboo Mission for Bamboo Application, NMB. Though the present government has very recently said that we are tying off everything bamboo, I don't know why, but it was there till 1 year or 2 years back. And then there are some collaborative projects going on with Strada, this of UK, and EPC in Bangalore for bamboo ply, whether they can make. So what are going on? And finally, its recognition has been done by in 2005. First time it was this section 3, section 6. Part 6 is structure. Subsection 3 is actually it was 3A, 3 was timber. Now it is 3A is timber and 3B is bamboo. So it's been included in the code, and they have, as I mentioned, 16 species identified, but all values are not available as of now. So that is a huge work which we can contribute and which people can then use for their purposes. So people are doing work, and obviously works are done more outside India and then us. I am sure you are very much familiar with these two buildings. So work is going on in architecture. Zeri Pavilion in Hanover by Simon Willis, or this bamboo wing of Fleming Daylight is in Vietnam by Bothong, architects who won the 2014. This particular wing got the prize for 2014. This is a competition on. I think I remember the competition. They won a prize for that. So these things are coming up, and these are not exceptions. Many things works are being done, not in this India thing, but things are happening throughout the world, and not only in architecture. You see. Works are done in furniture as well. Okay, this is an example of a Katlamara bamboo chair in Tripura. Designer is M.P. Ranjan. He has died a few years back. He was in NID Ahmedabad. He was also associated with IDCI in Bombay. And this is another example by bamboo bench by Japan Creative is the name of the office by Stephen Diaz of Germany and Yoshiro Yamagashi of Japan. So they are coming up. So bamboo is being used internationally, not only as a piece of architecture, also as a piece of furniture. And not only that, as household product, it's coming up. For example, the bamboo pot, designed as Neo Green from Vietnam. And there is a hair dryer. Left one is a hair dryer 2.1. That was a speaker. And this is a Grand Prix winner in design festival in Hayes in 2015 from France. This design is from France. So works are going on. The thing is that we have to also take up this situation. So as far as so to conclude is that a lot of work has to be done for us. A lot of work is remaining. We have just we have done practically nothing. If you compare what is being tried for the last 15 years, especially in Colombia, especially in Japan and China. And like I just mentioned that about this, I have worked with bamboo Samāgam, fine. Then there are 750 more species. Out of them, 3 Sengal is given the code, the others are not given. So this is a work. Somebody has to do that work. I mean, somebody working with brick may not know the capacity. What is the 12.5 megapascal is the capacity of composite strength of first class brick? You may not know, but somebody has to do that, and then you are using it in your construction purpose. So somebody has to do that work. That is also architecture work. So that needs to be done, and then obviously